So given the following rectangle, fill the unknown lengths and areas. So what property we're going to follow is that this is the area model for multiplication. So every piece of area must follow the area model. Length times width equals the area. So when I look at this area here, which I'm just going to highlight, we know that it has a length of x. The width then must be 2x to be able to get an area of 2x squared. We can just do factors. We can divide to find that out. Furthermore, once we find out that length, we know that we can find out this area here because it must be 5 times 2x or an area of 10x. Again, we can figure out the length based on the area of 10. We have an area of 10, a length of 5. We know the width here must be 2. Okay, otherwise we can't get that area. And then we can take a look at this area up here. So I'm just going to undo that there. This area up here, we can work out by x times, so this x, length x times width of 2, we know that area must be 2x. So we know that x plus 5, this is a factored form part of this, 2x plus 2 must be equal to the area 2x squared plus 12x when we combine the like terms plus 10. In this question here, this is a reasoning problem. This can be a little bit harder, but we're going to break this one down. So when we have a reasoning problem, we have to kind of think of what the main ideas are and use some reasoning to be able to figure it out. So it says here, how many integer values are there for k, where k is the middle term, so that 4x squared plus kxy minus 9y squared is factorable. So first thing is, try to recognize that this x squared, the x squared, y squared on the outsides, as long as the middle term is an xy term, this is a quadratic, okay? The other part is, well, this has a leading coefficient of 4, so that means that we want to multiply the first and the last terms together, okay, to be able to factor that middle term, that k value, what we're looking for, the unknown k value. So what I've done here is I've drawn in my 4x squared and negative 9y squared, and I get the diagonal product here of negative 36 x squared y squared. Now I'm not going to worry about the x squared y squared because we already know that this pattern, x squared y squared, is going to generate an xy term in the middle. So to figure the k out, it's going to be based on the red areas here. They must add to k. In this case, because we have a negative, we know that that's negative. We know that we have to have minus on one axis and plus on the other to generate that negative 9y squared. So it's got to be plus something y and minus something y here. And again, we're going to get the x here, and we're going to have some coefficient on the x. Okay, and that's going to generate all the terms that we need. So the diagonal gives us negative 36, and we want to know how to split up that 36 into one positive factor, one negative factor, to combine to give us the k in the kxy term. Well, our options then are basically the factors of 36. So I've listed out all the factor pairs. So 1 goes with 36, 2 and 18, okay, 2 and 18, 3 and 12, 4 and 9, and 6 and 6.